Hello everyone. Welcome to this week's edition of CamLogic's Tech Tuesday. My name is Rob Carver and I'm an applications engineer here at CamLogic. Tech Tuesday is our free weekly 30-minute tips and tricks webinar. And today's topic is Product Template Studio, the HOB. But first, let's familiarize everyone with CamLogic. CamLogic has been in the CAD/CAM CAE space for over 35 years, and the company was originally established 16 years ago, initially focused on CAM, servicing mainly the tool and die shops in the area. As the market has evolved, CamLogic has evolved. Interestingly, working our way backward from the manufacturing to the conception of an idea or a design. Because we started toward the end of the process and worked our way to the beginning, CamLogic has the fundamental knowledge of what has to be done to assure that each step of the process will result in a product that will actually work or fit into the next phase of development. CamLogic has chosen to represent software and tools that enable our customers to fulfill the full cycle of product development. We consider ourselves integrators and partners for our customers, not just resellers. CamLogic employs a three-legged stool strategy. We partner with Siemens, offering the complete integrated Siemens portfolio for design, machining, analysis, and data storage and retrieval. We partner with 3D Systems for 3D printing and rapid prototyping, and Steinbeckler white and blue light scanners in Creaform for 3D scanning for inspection and quality. Now that you've heard a bit about CamLogic, let's move on to today's topic. Product Template Studio. We recently used Product Template Studio to alter some tool holders. This week, as a follow-up, I want to show how Product Template Studio can be used to make a family of gear hobs. It will help make the designing of a complicated part more of an automated process, saving you time in the long run by standardizing your model creation, ensuring the model is a template. You'll be able to quickly and easily create families of parts. Today's focus is going to be on the methods used to create a gear hob to use as a seed part for Product Template Studio, plan for Product Template Studio, and open PTS and create an interface. I did a brief PTS demo a couple of weeks ago, but Product Template Studio is such a versatile, powerful tool we can't mention it enough. As I said last time, it's best to have a plan in mind with working with Product Template Studio. You should think about how to minimize the number of mouse clicks it will take to do the job. And I'll repeat my friend Josh Bonzetti's favorite saying, is the juice worth the squeeze? When designing a part with PTS in mind, that's how we have to kind of look at it. If I put some upfront juice into my model, will it be worth the squeeze on the other end? So let's see how this might work. Here I have a gear hob. Some of you may recognize this. We used to use this quite a bit where I worked previously to create gear blanks, cut gears, that sort of thing. And a lot of you guys out there who are tool designers will recognize that there probably is going to need to be some refinement done to this model to get it to be a fully functioning model, but nevertheless, it's the basis for what will eventually become a functional hob. Okay. One of the things that we have to kind of keep in mind up front is the type of, you have, like I said, you have to kind of plan in advance for what you want to do. So let me open up my part navigator a little bit here and kind of unhide some of the features that went into creating this. We have a helix here. We have a couple of datum planes, okay, to limit the extent of my hob here. Okay, I picked an arbitrary dimension of 12 inches. Thinking that I can't imagine anybody needing a hob much longer than 12 inches, but certainly that can be changed. the helix here is I'll go ahead and edit that. You know, it's we have a function in there, formula. I've got I made it equal to my pitch diameter, okay? And that kind of leads me into kind of the planning for this thing. I knew that I was going to need some gear terminology in this, okay? So even though it's set to PD, that value of PD is 2.5. And so let me back up a little bit further and go into expressions, okay? And here you see a whole list of different expressions that I set up beforehand. I knew that I was going to need an addendum, so I have an addendum here, ADD I called it, with a formula of 1 over P. Here's my P. This is the pitch for the gear. And in this case, it's not necessarily the distance between teeth. It's a gear terminology. In gear terminology, this would be the pitch. It's based on a combination of different things. I won't go into that right now. But here we have a value of 6 in it, so my addendum would be 1 divided by 6. Here's my arbor diameter. Now that's just a straight type in 1 1/4. If I want an inch in there, I put an inch in there. Here's a number of different other formulas. Here's my circular pitch, CP. Here's my dedendum value. Now this gash angle, I'll explain that in a little bit. Key height, okay. Key width. So if I want a 1/2 inch key here rather than a 1/4 inch key. Here's the number of teeth that I have in my that I want on the gear that I want to cut. So this enters into some of the formulas that go along with creating the hop. So here's a whole list of different expressions that I created beforehand, before I really even started designing the parts, so that I would know, so I'd have them to use before, as I was creating the model. Okay. So let's see. Let's go and make this our current feature. Where did it go on the list? Here. Kind of moves around on me. Well, let's just go ahead and edit. We'll roll back then. Okay. As you can see, it's just a very simple sketch, and I've got it as my OD, and the formula on that is my PD plus my addendum. Okay. Finish that sketch. Goes back. Let it regenerate. Okay. And you know, get my tooth. There's my arbor sketch. Okay. Now the arbor sketch I pulled right out of the reuse library, out of the 2D sections. Pulled that right out of there, and I just drug it right in and used that. So here's another thing that to keep in mind is your reuse library. Okay. Very, very handy here, and you can add your own sketches and whatnot to that. So, but we'll save that for another demo later on. Go back to here. This is the sketch that I used for my shoulder diameters. Again, edit that sketch. Okay, and here again is one of those one of those expressions that I created beforehand. Okay. Finish that sketch. There we go. And finally, here's our datum planes. Again, I said that's our fixed length. Okay. And finally, our tooth form that I used. Okay. Very simple. Again, here's some of those predetermined expressions in here. Here's my pressure angle, my base tooth thickness, the D-denum and A-denum. Okay. And I just created that sketch right on that helix. Okay. So instead of sketching on a plane, it's a sketch on a line, sketch on a path. Okay. So I'll finish that one up. So basically, I don't want to spend an awful lot of time on this, but these are all different elements that I use to create this sketch. There's a second helix in here, right there, that I used with this sketch in conjunction with this sketch to create these gash angles here. Okay. So with all that in mind, now let's kind of move into the product template studio. Okay. So I'm going to close this back out. Now that I have this part saved as a you know, with all my expressions in mind. Okay. I'm going to close it. Actually going to exit out of NX and bring up my product template studio. Select my part as my template. Okay, here we have a nice little picture of it. And here's our interface that I've already created. I probably should have backed up and used this interface to show you how part updates, dynamically updates, but we can go back and do that in a few seconds. Okay. This is the interface view. This eyeball looking thing, this eye view here. This is actually what holds all of the expressions, all of the patterns, all of the features that's inside that model. So one of the things that we might want to control here, we have our pitch, we have our pressure angle, we have our overall length, the gash angle here already established. Let's go, maybe we want, let's add something in here. It would be nice to know in advance, kind of name these different expressions in advance, what you'd like to add in. Here's one right here. I know that this is my pitch diameter. Okay, this might be fairly important, something that we want inside of our gear hob. Okay, so we just grab that, bring it in, stick it up underneath there. Now we can go ahead and rename it. pitch diameter. Okay, it's a key-in value. All right. And if I look at my view, my interface, we can see that it's been added here. Okay. Now, something else we might want to add. Maybe you want to have a help screen or something of that sort. We can go and drag from this side here a bitmap, a spot for a bitmap, okay, and drag that right under there. Oh, that's, and it doesn't want to give it to us. But let's give it a, let's go find a picture anyway. Okay. Libraries, documents. Should have your bitmaps on over there. Just a second here. Here we go. Users. My pictures, and we'll go find a bitmap to put in there. Maybe you want a company logo or something in here. I won't bother putting a company logo in, but we can certainly have a little bit of fun here and say, okay, this is the Sir Graves Ghastly helical hob cutter company, or we can go in with something else. Maybe we want a help document or something like that in there. So we could go you know, that might not necessarily be appropriate. So let's see. It's usually good to have an appropriate picture in there. Okay. Something that would be, you know, you could have a bitmap here that's got you know, labels that would help a new user or one of your new engineers go in and know what the different things are in this list that he's changing. Okay. So we can go in and save this now. All right, and just for grins, we'll go in File and Publish. And we get the nice little sound that tells us that everything is all right with the world. And now we'll come back and restart NX. Okay. There, we should see that now. Okay. All right. Now, if everything goes well here for me, we'll go into our assembly navigator and right mouse click on our part, and here's our user interface that we've created. We've got our gear hob here, so if I go in and maybe change my overall length, okay, key in a value of just 4 inches, I should see that shorten up. And there we go. Notice that my shoulder widths and everything went with it. Let's see if I change my pitch, key in a value is 8. I should see my teeth change in size. Okay, they got finer. All right. And as I said before, I was going to show you what the gash angle was for. Okay. Now, obviously, you could go in, you could set this up any way you want, so you could have a different number of gashes for these flutes. Some companies call them gashes. Let me go in and just alter that. So that what I'm actually doing here is that I've created an interface, a product template studio, where I'm altering my expressions. It's an easy method of altering the expressions and the power that NX has with expressions. Okay. Obviously, there's a lot more that can be done with this. The initial idea behind this cutter is to give a new user to NX a means of creating a complicated part. There would have to be a lead engineer or something that would actually set the C part up first. Your new engineer, somebody that's not all that familiar with NX, you go in, do some initial changes on here, hit OK. Save this part off as a new part file, and then do a little bit of cleanup work here. Now we'll just go in, show a little bit of the power of synchronous modeling. So we've got these little flyers here on the end here that we just want to get rid of. All right. So now we can use some very simple synchronous modeling techniques to do some quick cleanup on it, and we have a part file. Okay. Whoops, I got to add that little guy in right there. There we go. So very quickly, you can go in and start doing some cleanup work, save it, you've got yourself a new part file, and you're off and running. So I think that's about it for this demo at the moment. So I'm going to go back to my presentation. Okay. So you can see how very quickly and easily you can go in and create with some upfront work, putting some juice into the model. It's well worth the squeeze on the other end. And we can't emphasize enough the importance of training in today's technology. Okay, with today's technology, to get the most out of the purchase of NX. It's well documented that training helps improve the speed of use, increases efficiency, provides faster problem resolution, it leads to fewer support calls, all of which positively affect the company productivity, return on your investment, and the bottom line. At CamLogic, we offer a wide variety of hands-on and instruction-intensive courses for users at every level. Training is available at the on-site location of your choice or at one of our training labs located throughout the Midwest. And for more information or to register, please visit our website. Today's webinar can be found on YouTube, usually within 24 hours of the broadcast. Check out CamLogic on YouTube for past webinars as well. And thank you for joining us today. If you have any questions, please feel free to call me or email me. Be sure to visit our website at www.camlogic.com. We can also be found on LinkedIn, Blogger, Facebook, YouTube, and Twitter. Our new help desk number is 855-955-0900. This concludes today's edition of Tech Tuesday. Thanks again for tuning in, and have a great day.